Alright, this is Math 8, Chapter 1, Lesson 10, looking at comparing real numbers today. And so we've been looking at the number system for most of this chapter already. And so when we look at the number system, we kind of come back to this one of the initial charts we talked about, looking at rational numbers and irrational numbers. And rational numbers are numbers that generally are going to be things we tend to work with. Whole numbers, our natural numbers, counting numbers, whole numbers, integers or negatives and positives, as well as some fractions, repeating decimals, and percents, things of that nature. Our irrational numbers are things like pi, or decimals that repeat but don't actually, decimals that go on and on forever but don't have a repeating power. And some of those things are found out when you do square roots of certain numbers. They just tend to go on forever and ever and ever, and that's what makes them irrational numbers. So we're looking today at identifying different types, whether they be rational or irrational, or how they fit in that category of rational numbers there. But we're also going to be comparing them in terms of their value on a number line. To do this, I'm not sure your teacher taught you there, but you'll probably need to use a calculator to solve some of these problems here as you work through them. So let's take a look here at page 93 in your textbook for naming the sets of numbers to which each real number belongs to. When I look first of all at 2/3, if I was to do the math on that from back in the beginning, this becomes 2 divided by 3.000 there, and we find out that it goes in there 6 times, and that's 18,206, and it keeps repeating. So because this is a repeating decimal, we would say that it is a rational number. That fraction is rational. It goes on in a repetition type way. For the square root of 20, the square root of 20 doesn't seem to have any number that repeats there. So for me on my calculator here, what I tend to do, how I make my calculator work there, is I'm going to do my second function in square root, and I'm going to put 20 in my parentheses and press enter. And we can see I get 4.4721,359. There's nothing repeating there. It just seems to go on and on and on forever. So we would call this an irrational number there. For 7.2, we see this is a whole number there, and this part here is repeating the whole way through, and so this would simply be a rational number. 12 divided by 4, or 12 over 4, can also be written as 3, and 3 tends to be a natural number, one you count with. It's whole because that's a natural number including the number 0. It's also an integer, which is what you get positive and negative numbers, and it's also rational. So this is the first one that belongs in several different categories. So 12 over 4 is a natural whole integer rational number. Moving down to the next section here to decide whether it's greater than, less, or equal to, you'll need to use your calculator once again. So to find the first one, I'm going to take the square root of 10 and find the square root of 10 is 3.162 and a whole bunch of other stuff. So 3.16. That tends to be less than 3.2, and so I'd fill it in like so. On my next one, I have 5 and 1/6 and 5.16 repeating, so this goes on and on forever. So if I was to take what is 1 divided by 6, 1 divided by 6 is 5.1666. Again, it tends to be repeating there. So this ends up being the same thing. I know my calculator shows a 7 there, but that's because my calculator is going to kind of round at some point and just stop, so it doesn't go on forever. So the point is, these are equal to each other. When I look at the next one, I have 2.2121, and it goes on and on and on forever. So let's find out what the square root of 5.2 is. I push my second function and square root. I put in 5.2 and equal, and I end up with 2.28. So here I have a 2.21, and here I have a 2.28. So the 8 is bigger than the 1, and that's the way that one's going to work there. Alrighty. Let's look at a couple more real quick, and then we'll wrap this lesson up. We have to take these numbers and place them in order from least to greatest and verify it by putting those numbers on the number line in the right order where they go. Okay, so let's take a look here first of all at, we'll do number 9 together. Okay, so if I take these values here and do the square root of 5, the square root of 5 is 2.23 and I can write a 6 there. No problem. When I find the square root of 6, the square root of 6 happens to be 2.449. I have 2.5 right there, 2.55 there, and 7/3 is 7 divided by 3, which is 2.3 repeating. So when I look at my numbers here, at 2.236, that's my smallest one, 2.236, so we're going to be somewhere around here. That's going to be where I put the square root of 5. My next value, I have 2.3333 repeating. That's going to be somewhere around here, between 2.3 and 2.4. So my value of 7/3 will go there. So there's that one. My next value is going to be 2.449. So we're over here, we're about 2.449, somewhere in the middle between 2.4 and 2.5 is the square root of 6. My value of 2.5 is simply right there at 2.5, and 2.555 is bigger than that at 2.55 right there. So now I have my 5 points plotted in least to greatest order. If I was to write that out, I would say square root of 5, 7/3, square root of 6, 2.5, and 2.55. Alright, and those are my numbers in order from least to greatest. The rest of the problems are very similar to that. Again, you want to use your calculator to solve a lot of these problems, and just take your time with them, make sure you're doing it right. Hope that helps a little bit. Good luck.